Well, hello there, and welcome to the first in a series of educational physics videos from D-Note Lessons. In this video, we're going to look at the life cycle of stars. Now, let's get started. All stars initially form from clouds of dust and gas. Eventually, the force of gravity pulls these together to form a protostar. This gravitational energy is converted into heat energy, so the temperature rises. When this temperature gets high enough, hydrogen nuclei undergo a process called nuclear fusion. Through this, helium nuclei are created. This process gives out masses of heat and light, leading to the birth of the star. The star then enters a long, stable period in which the heat created through nuclear fusion provides an outward force to balance out the force of gravity pushing inwards. This period is maintained for millions and billions of years. We call a star in this phase a main sequence star. Eventually, though, the supply of hydrogen begins to diminish. Heavier elements such as iron are produced, as opposed to helium. The star now enters a new stage of its life. From here, there are two pathways that can be taken. If the star is small, well, I say small, but roughly the same size as our Sun, then it will swell into a red giant. However, if it is a big star, much larger than our Sun, it will swell into a red supergiant. Firstly, we'll go on to discuss the further stages of a smaller star, or a red giant. As a smaller star reaches the end of its stable period, it begins to swell into a red giant. Over time, it becomes more unstable and its outer layers cool. It begins to eject some of these layers of dust and gas as a planetary nebula. This leaves behind a hot, dense, solid core called a white dwarf. Bigger stars, however, swell into red supergiants as they reach the end of their main sequence period. They start to glow brightly again as they undergo more fusion and expand and contract several times. Eventually, they explode in a supernova, forming elements heavier than iron and ejecting them into the universe. What is left behind is a very dense core called a neutron star. If the star is big enough, this will become a black hole. That's all for this video. If you have any questions or requests for future videos, please let us know. Thanks for watching.